friends, and in this video again we are going to start making videos about the solutions of the CBSE 10-12 NCERT exercise 7.7. This chapter is also based on the integration by parts, but this has some special forms, and we are discussing the three special forms actually, and then we will be discussing these three special forms individually, and then we'll go into the exercise and solve the problems based on this. Now somebody told me that why mathematicians always frown, can't they be smiling? But why not? We can always smile. There's always a service. Don't worry. In these questions, in these videos, I'll try to be smiling and solving your question. Let's see what kind of difference is going to make your understanding. Now, so here I have one first form which goes like, how to find the integration of under root x square plus a square dx. The method says that since integration by parts always involve product of two functions and the hierarchy is IIT, so I need one more function. So let me introduce one function which is omnipotent, and that is 1. So using the formulas again, this is what I'm going to keep, this under root x square. This is my u, this is my v. So keep u thing constant. Integration of 1 dx minus integration of differentiation of what was unchanged, that is under root x square plus a square, and multiplied with it the integration of 1 dx again and dx. This is the rule of uv says so. So this becomes under root x square plus a square, integration of 1 dx is x minus integration, this is differentiation of root x. You know that d by dx of root x always gives you 1 by 2 root x. Now d by dx of root something will give you 1 by 2 root something into differentiation of that something. So it becomes 1 over 2 root something, that is x square plus a square, and into differentiation of this something on the top, this will become just 2x. And this part is as usual x only and dx. So there I write in the proper order, that is x under root x square plus a square minus this 2 and 2 cancel each other, and then we get x square minus integration x square over x square plus a square dx. Then what do we do? That in the next time, to get the form of this x square plus a square, I add and subtract this a square. So I do it here only, but I will use my red pen now. So I add a square and subtract a square. Then what difference is going to make? This one is splitting your integral in two parts. That is, one is x square plus a square over under root x square plus a square dx minus, and this minus makes it plus, and that is a square. I take common because a square is constant, and there I'll get just 1 over under root x square plus a square, and this is x under root x square plus a square. This is your I. Now if you pay attention to this part, this is very vital part, just you have to pay attention here. That is x square plus a square over under root x square plus a square is nothing but under root x square plus a square. It is just very much same like 2 over under root 2 is just under root 2. Now this is so self-explanatory. So instead of this term, I am going to write this whole thing as under root x square plus a square dx. Now if you say, if this is I, this is also I, and this is minus, so this I when comes on this side becomes 2i, and this part is already integrated, that is x under root x square plus a square minus part is already gone, so we are just left with this a square, and this is directly the formula, that is log mod x plus under root x square plus a square plus c. So now this is 2i, so just put 2 here 2 here, remove this 2 from here, and this is your final answer. That is I is x under root x square plus a square by 2 log mod x plus under root x square plus a square plus c. This is the formula. Now we have one more form, and that is I is under root x square minus a square, but the same method I have to use. So I do just make changes to this. One by one slowly you'll find this is, you have to make this one as minus, this one becomes minus, this becomes minus, this becomes minus, this becomes minus, then there it is, you get this x square, but we have to find x square minus a square, because this also will become minus, this becomes minus. Then the one difference, instead of this writing x square plus a square minus a square, I'll just write this as minus first. Same thing, is just I change the order. It means minus a square and plus a square. See, so this x square minus a square is this. Now this will become minus, no change. Now this is minus and this is plus, so this also will become minus. This is a square over this becomes minus. This is minus. This part is minus, and this is done. So we have just derived just by changing the minus into this. This is the second formula, which goes like I is a x under root x square minus a square over 2 plus a square by 2 log mod x plus under root x square minus a square. And here this one I forgot to make changes, this one will be minus. So this is minus, in the previous case it was plus. Now the third question is just a square minus x square. So now I'll do the same thing. This is a square x square, a square minus x square, a square minus x square. This is gone, a square minus x square. Now there, when you differentiate a square minus x square, you'll get minus 2x. That is the only difference. So this 2x will become minus 2x, and this is a square minus x square. Now instead of this is minus, and there I'll get minus x square. Okay, this is same thing, a square minus x square. This is similar, a square minus x square. Now there I'll add a square and subtract a square. So a square minus x square. This minus, this becomes same as it is, going to the same pattern, a square minus x square. This minus and a square minus x square over this will give you same thing inside the root, that is a square minus x square. And then this is this minus, sorry, this one here I made a mistake, it's a square. So a square minus x square minus a square. So this part minus a square minus x square over this gives me this same thing, and this part will become plus a square over this part is again a square minus x square. Now this part same, this one will become a square minus x square. This one will become plus a square by 2, and instead of this integration of log mod something that was for 1 over under root x square plus a square, or 1 over under root x square minus a square, here we have 1 over under root a square minus x square, and this will become sine inverse x over a plus c. So all these three formulas derived. Now we'll go into the exercise, and then we'll just try to check the form, and then we'll directly write the answers. Now exercise 7.7, question number 1. How to find integration of under root a square 4 minus x square. 4 minus x square. then you can write this as under root 2 square minus x square dx. Many people use the formulas directly because right now the formula says that formula I is under root a square minus x square dx is x under root a square minus x square by 2 plus a square by 2 sine inverse x by a. So same thing, just at the place of a you write 2. So this is formula, you can say formulas, and then here our integration will be just this is, so x under root a square minus x square is 4 minus x square, 4 minus x square over 2 plus this is 2 square by 2 sine inverse x by 2 plus c, that is x under root 4 minus x square by 2 plus 2 sine inverse x by 2 plus c. This is done. Question number 1 is gone. Question number 2, this is 1 minus 4x square. 1 minus 4x square. You can write this as 1 square minus 2x whole square. So if you write 2x as t, 2x as t, then you get x dx as, sorry, just 2 dx as dt. So dx is dt by 2. So it means we have, at the place of dx we have to write dt by 2, means all the answer will be multiplied by half. Okay, the formula again goes same way here. Then now I don't need this part, my integral will become half, and then I use the formula, same formulas again, because again it is a square minus x square. Then what you get? You get t under root 1 minus t square over 2 plus a square, that is 1. So 1 by 2 sine inverse t over 1, that is this, and this half is coming extra because of this dx is dt by 2. Now just multiply this and just same time replace the value of t as 2x. So this becomes 2x under root 1 minus 4x square over 4 plus 1 over 4 sine inverse 2x. Now 2x by 4 can be written as x by 2, and this is your integration. This is your answer. We are missing just constant of integration, and this part is done. It goes that find the value of I is under root x square plus 4x plus 6 dx, and that is, if you write this as sum or difference of 2 square, what do you get? X plus 2 whole square. So x square plus 4x plus 4 is consumed, you are left with just 6 and 2, that is under root 2 whole square dx. So if you use this formula, then you get this already getting in the form of under root x square plus a square, and the formula says that, let me write the formula in the red color, that is I is integration of under root x square plus a square dx, that is x under root x square plus a square over 2, and then we have plus, or we have minus a square by 2 log mod x plus under root x square plus a square plus c. This is the formula which we are going to use. Now, okay, so this is the formula, this should be plus. So this is the missing part. Now you can use this formula directly, and then you can write your answer as I as x. At the place of x you write this whole thing. Why? Because even if you take x plus 2 as t, you will get dx is dt. There is no change in the coefficient, it means everything will remain same. So this becomes x plus 2 into under root x square plus a square, means this whole thing, there is nothing but x square plus 4x plus 6 upon 2 plus a square, which is root 2. So a square is 2. 2 over 2 log mod x plus 2 plus under root, that is x square plus 4x plus 6 plus c. Now 2 by 2 you don't need, this is c. So this is your answer. So next question is question number 4, and this is x square plus 4x plus 1. Then what happens? You can write x plus 2 whole square, but you have x plus 2 whole square plus 1, and for this only you need x square plus 4x plus 4. It means you need minus 3, that is minus root 3 square. So the form is under root x square plus a square minus root 3. If you expand, x square plus 4x, and when plus 4 minus 3 will give you 1. So this is fine. Now this goes in the form of x square minus a square. Now I have to change the formula. This is minus. Whenever you have this minus, wherever you see plus, make it a minus. This is minus. Done. So in the case of this, right now we have x plus 2, that is fine, and when you write whole thing square, this will become x square plus 4x plus 1, and this thing, that is a square by 2 with this square, that is 3 by 2 log mod x plus 2, that's fine, plus under root this whole thing, that is x square plus 4x plus 1, and this is the answer. It's done. We have question number 5. This question number 5 goes like I is integration of under root 1 minus 4x minus x square dx. The problem is that suppose if you don't remember the formula, then what will happen? If you don't remember the formula, then will you ask someone who is sitting beside you to tell you the formula, or is there any way by which you can derive the formula? Yes, you can derive the formulas. All these formulas have been derived only. There is no problem with that. So now I write down 1 minus 4x minus x square. Just take minus common. This will become x square plus 4x minus 1. So you write here minus x square plus 4x plus 4 minus 1. This gives you x plus 2 whole square, and this is minus 5. If you keep this minus thing inside, this becomes under root 5 whole square minus x plus 2 whole square. So now at the place of this you can write this is under root 5 whole square minus x plus 2 whole square dx. Okay, then again we can apply integration by parts. So let me get to your, fine, I'll do it later. So you just say that let x plus 2 is t, so dx is just plain dt. So in this condition my equation becomes under root 5 square minus t square dt. Now I go directly and integrate, taking this 1 dot under root this is my u and this is my v, and the differentiation goes with respect to dt now. So I becomes t under root differentiation of this one, this one remains unchanged, and integration of 1, that is giving me t, that is under root 5 square minus t square minus integration of this is t into differentiation of this, that is 1 over 2 under root 5 square minus t square into differentiation of this gives you minus 2t dt. Yes, so this I now becomes t under root, I write this as just 5 minus t square minus this 2 and this 2 cancel, this is just minus t minus 2. Yeah, so this 2 and this 2 cancel, you get just minus t square over under root 5 minus t square as it is. Now I add root 5, or just I add 5 here. 5 is just root 5 square, so I am writing 5 minus t square, and then I write minus 5 here also. Then I remove this part, I need some space. So Ri now becomes t under root 5 minus t square minus this 5 minus t square over this directly gives me under root 5 square minus t square dt plus this remaining part gives me 5 outside dt over under root 5 square plus t square. This is root 5 square. Okay, so this part becomes I, this comes on this side, it becomes 2i. So 2i is t times under root 5 minus t square minus this is 5. This is log dx over, this is dx over root 5 square t square, root 5 square plus t square, that is 5 log mod t plus under root t square plus root 5 square plus c. So this I is half. Now at the place of t, what is t? T is x plus 2. So write this as x plus 2 and under root 5 minus t square just nothing but the same thing. That is 1 minus 4x minus x square minus 5 log t is again x plus 2, that is x plus 2 x plus 2 plus under root this whole thing again, that is t square plus this is again I think I have written one mistake I have done. This is 5 minus t square, this is also minus and this is also, this will be written as root 5 minus t square. Yes, so done. So this is 5 minus t square, that is 1 minus 4x minus x square plus c. This is answer. Sometimes when the question becomes little lengthy, this 5 by 2 also. So this 2 goes there, this makes 1 by 2, 5 by 2. Sometimes when the question goes lengthy, that if you don't feel that whether the students are liking, but whether you like it. So sometimes it becomes little complicated, like to which particular method should I pay more attention to that, because I don't feel like that whether the students are going to like this complicated situation, but there is no way, whether you like it or not, you have to learn. Now this is question number 5 is done. I derived it without using the formula, but if you remember the formula, these 3 formulas what we have discussed at the beginning of this video, if you remember those 3 formulas, you can do the question directly. Now remaining questions I am just going to use the formulas only. Question number 6, I is integration of x square plus 4x minus 5 square root of x square plus 4x minus 5 dx. So I can write this as under root x plus 2 whole square and this is minus 9 dx. If you expand you get plus 4 here and the plus 4 minus 9 is minus 5. So I want to write this as x square of something, so the 9 I can write this as 3 square. Now I'll use the formulas directly because this is the form of under x square minus a square. So which goes like I is half x means x plus 2 under root x square minus a square means this whole thing, that you can write x square plus 4x minus 5 directly, then minus a square by 2. So a square is this, that is 9 by 2 and log mod x plus 2 plus under root expand this x square plus 4x minus 5 plus c. So you can't write the answer directly, it just looks like someone have taken the question and written the answer. You have to write that since we know that I is under root x square minus a square dx is this, that's why using the same formula I am getting this particular form. This is done. Now I'll go for question number 7. So I am using the formula directly and I am not writing the formulas because I have written at the beginning of the video. So it is just kind of suggestion. Don't think that only this way you can get it done. So that is 1 plus 3x minus x square and this whole thing is under root. So this bracket is not required. I can write this. this one. Now just I have to express this in terms of sum or difference of two squares. So just take minus common. This becomes x square minus 3x minus 1. This is minus. This becomes x minus 3 by 2 whole square. And then at the end of this, because plus 9 by 4 have been compensated, minus 1 minus 9 by 4. Minus 1 minus 9 by 4 is minus root 13 by 2 whole square, just like this. Now compensate this, this becomes root 13 over 2 whole square minus x minus 3 by 2 whole square. So this is going in the form of under root 13 by 2 whole square minus x minus 3 by 2 whole square dx. So this is directly in the form of under root a square minus x square. Now I am getting the answer using the formula, but at the same time I am not writing the formula. You have to write here. We know that under root a square minus x square is this, and that's why this whole thing becomes half x. So what is x? X minus 3 by 2, and then under root a square minus x square means this whole thing, that is 1 plus 3x minus x square. Then you have to write plus a square by 2. So what is a square? This by 2 means under root 13. This becomes 13 by 4. If you write divide by 2, this will become 13 by 8. Sine inverse x upon a, that is what? 2x minus 3 over root 13 plus c. I think this is the answer. Question number 8 and question number 9. I am just changing the form, and the rest is you have to do on your own. That is under root x square plus 3x. That is under root x square plus 3x dx, and this is I is under root 1 plus x square by 9. 1 plus x square by 9 dx. So one more is there. Why should I leave that one? That is question number 10. Question number 10. This is I is directly fitting in the formula, that is 1 plus x square. 1 plus x square dx. Now this I can be written as under root x plus 3 by 2 whole square minus 3 by 2 whole square dx. Directly is fitting into the form. That I can be written as, you can write this as 9 plus x square under root 9 plus x square upon under root 9. This goes outside and becomes 1 by 3 under root 3 square plus x square dx. So this is directly fitting in the form. Use the formula, get the answer. This is directly fitting in the form. Use the formula, get the answer. This is directly fitting in the form, and use the formula, get the answer. These two will be solved using the same formulas, because these two have the form of under root a square plus x square. This is in the form of under root x square minus a square, and by using this you can take it as your homework, because only watching videos of others is not going to help you. You need to develop some sense of accountability also, and after watching so many videos, this is your duty to start solving the question, okay? Otherwise you are going nowhere. Thank you very much. Just subscribe to our channel, and we are done with indefinite integration, and in the next video we'll start definite. This is the end of our videos on indefinite integration. That's why I have given you these 3 questions as homework. I have already solved. If you still cannot solve them, then for God's sake, write there in the comment section, and then I'll solve it for you. Thank you very much.